Let's decipher the rules of IUPAC while naming an organic compound. So here you see the common name is pentamethylene dichloride. So what does this penta tell you? Penta tells you that there are 5 carbon atoms. Methylene is nothing but CH2, and dichloride means there are 2 chlorine atoms attached to it. That's the common name given, pentamethylene dichloride. Since there are 5 carbon atoms over here, what we do is we write here those 5 carbon atoms first. Now chlorine is, now first what we have here is CH3. Then we have here CH, and then this is Cl. This is again CH, and this is Cl, and this is CH2, and this is CH3 over here. So if you count the number of, first rule is identifying the longest chain. The longest chain of carbon has 5 carbon atoms over here. So the root word is pentan. How many hydrogen atoms over here? 3, 4, 5, 6, 7, 8, 9 and 10, and there are 2 chlorine atoms. Now this chlorine is an halogen functional group, and it is at, from where will the numbering start now? The numbering of the carbon atom will start from the nearest carbon atom. Carbon chain will start from here. This is 1, this is 2, this is 3, this is 4, and this is 5. So the position of this halogen is in the second carbon atom. It is attached to the third carbon atom. So 2, 3. So first thing is check out the longest chain. Then identify the location of these halogens or the functional groups where it is attached, and then accordingly, as we already know, it is first prefix, then comes the parent name, and then comes the suffix. So we are, since it is an halogen over here, since it is a halogen and it is chlorine attached, what we use is the prefix used is chloro. Okay, the prefix used is chloro over here. Since there are 2 chlorine atoms over here, so that is why the word dichloro. So what is the position given here? So the rule is 2, 3. So whenever there are 2 positions given, then how will you identify those position is by putting a comma between the 2 numbers. So 2, 3, then a hyphen, because number and the alphabet there is always a hyphen, then comes dichloro, and then comes pentane. I hope this is very clear. Now moving on to the next one, here we have butyric acid. Now in this butyric acid, as you know, since it is butane, so there has to be 4 carbon atoms. If you see here, we will put 4 carbon atoms here, right? So this is CH3, CH2, CH2, C double bond O and OH here. This is a carboxylic group. So what it ends with is oic. So butanoic, butan. So butanoic acid, it becomes butanoic acid. I hope this is very clear. Butyric acid, the common name and IUPAC name is butanoic acid, because there is a carboxylic acid functional group attached to the very first carbon atom over here. So we don't have to give any number to it. So it is simple butanoic acid. Moving on to the next one, we have N-propyl bromide. Again, N indicates it is the first position. Propyl is C3H7 and bromide is Br. So bromine becomes bromide. So here again bromo. Bromine becomes bromo. So this is functional group attached bromine. So it becomes bromo. It becomes bromo. So you have here 1 bromopropane. Propane, because this is the root word will be propane. So 1 bromopropane. I hope children, you all have understood, and I will be coming up with some other examples, that is esters and ethers as well. Till then, please subscribe to my channel, share, hit the bell icon, like and share, and if you have any queries, do put it in the comment box.